22, our first even should have been approximately 81.2 feet. Hopefully you saw opposite and adjacent and used your tangent. Remember, whenever you have an angle, whenever you are given or finding an angle, you have to use SOHCAHTOA. Hopefully not Choshikawa. Who wants to use a cosecant if we can use like a sine instead? But use your SOHCAHTOA whenever you have an angle. 81.2. If you were in radian mode, it could look gorgeous and be wrong. Change your mode to degrees. That's it. Yeah, if you wrote down tangent and it didn't work out right, change to degree mode. It very well could be that you were in radian. If it doesn't work, Aiden, let me know. After 22, I'm sorry, I was 34? Yeah. 34 was a little weird because they didn't give you a distance, they gave you a speed. Which meant you had to build a bridge. You had to build a bridge because they were talking about minutes, and so you had to build a bridge to get rid of those seconds and do some unit conversion. Dimensional analysis. Shout out Mrs. Leon. If you multiply by 60 to get feet per minute, then you could say after 1 minute, how far did they go? Or you could have just multiplied by 60 to be like, there are 60 seconds in 1 minute. After 1 minute, they traveled 16,500. You had to use the speed clue to figure out how far they went. And then it was a simple opposite over hypotenuse. Use the sign and then solve. Once again, if you weren't in degree mode, it's going to be a little weird. So check your formula. Did it work? So anyway, 5,099 feet. You had to find the distance. They just gave you the speed. And then letter B said, we'll tell you the altitude. They've gotten up to 10,000 feet. How long did it take them to get there? You could have gone ahead and said, well, you know what? This side that we just found up here, this hypotenuse is found by 275 times how many seconds, or you could have done times how many minutes. In seconds, it'd be 117.7, but if you had used the minute one from up above, then it would have just been 117.7 divided by 60, which would be approximately, what, 1.9-ish? It's really close, 1.8, 1.9. Did anybody do it in minutes? Sorry. But anyway, you could have done it in minutes just by dividing by 60 or using the number up above. And then the last one was number 62?
Yes.
Oh, I saw 62. That's okay, I have it open right here. Let's go find number 62 and figure out what's going on and why it's not. Chapter 4. Do you guys have any other questions besides 62 that you want to go? Oh, great. Doesn't show up. That's good. Okay. Anything else besides number 62, though, that you guys want to go over? From homework last night, evens or odds? Oh, one's all over. Sid, what do you got? Which one? 23. Aiden, what you got? 29. And then Kayla? Oh, yeah, go ahead. 23 and 29, that's it? All right, let's go check out 62 first because he's that even that we need to grade. Remember, if you guys are bored at any point during these homework questions, you know what you can do. The review you've already written down. And if you haven't gotten a book yet, you can quietly, without distracting anyone, come on up and grab one. Number 23, 29, got it. First, 62. Oh, 62 is a true-false question. I gave you this true-false question because we didn't really get to talk about bearing in class, and we're not going to, I didn't give you any super crazy, super weird word problems with bearing, even though I could have, and even though honors totally didn't struggle through. Bearing is just another way of measuring angles, and it has to do with the compass. Some of you might have known that this was definitely false. Ooh. Definitely false. And some of you might have been like, I don't know what a bearing is. All right. For a bearing, just how to do the angle without making a big deal in notes or doing tons of word problems on it. You guys at least know from any, I don't know, random point in space, it has a north, it has a south, it has an east, and it has a west, right? We live in the west, maybe. Unless you're in China, then I guess we're kind of on the east, aren't we? Right? It depends on your reference point. It depends on where you are. True? Asia used to be called the Far East, but it's west of California. But where was most of the civilized world? Well, yeah, okay, now it's that. But the people who were calling it the Far East, it wasn't the people living there. They're like, we're here, right? So like the European culture, where was Asia? To the east. It was called the Far East because it was to the east. I think in Bible times, it was right around there in that Fertile Crescent, right? It was to the east. Anyway, but north, south, east, west. All right, cool. West Coast, that's where we are. East Coast, that's where everything else is. Just kidding, like New York, Virginia, all that jazz. That's where I was born, South Carolina. Anyway, south, not north. And then, okay, go. Santa's up there. So, how do bearings work? North, go there first. 24 degrees, turn that. East, what direction? Oh, that's west. It's a different way of measuring where you're using the north, the south, the east, the west, instead of just using like, ooh, we're robot math students and we always start from here. But when you're in the real world, like, no, maybe a compass and maybe the North Star would be a much smarter place, in depending on what point of history you were, to measure from. But anyway, bearings, how do they work? You start to the north or the south, and then you turn towards the east or the west. So when this says 24 degrees north of east, they're going the wrong direction. Why would you start from east? Start with north and then turn east. Anyway, once again, not giving you crazy, super hard bearing questions, but curious if you would go figure out what a bearing is and how it works. Anyway, long story short, balls. All right, you guys had questions on 23. Well, because I just showed you what the wording was and how it was wrong. The wording said go north from east, when it should have been go east from north. Does that make sense? So 24 this way is way different than 24 that way. Sorry, I didn't realize I wasn't being clear. I apologize. Number 23. Oh, there's a witch float. Could be like the Macy's Day Parade. 23. It's number 31. I'm not sure if I gave you guys that one. Hey, tomorrow on the quiz, let's use 23 as a learning experience. Do you guys remember that in chapter 4, sometimes minutes and seconds appear? Now, most of you did generally pretty well on chapter 4a when you had to do minutes and seconds, but can we remind ourselves really fast if we're in a calculator how we find those? Although it's taking forever to load. As it does load, though, they didn't give you a picture, and those are always the hard ones, right? And now it's frozen on that screen. We love computers. Yes, we do. Okay. There's a point. I don't know. There's a church. The church has a steeple. There we go. Now I can see it. And we have a right triangle. So if you didn't know how to... Hi. Remember that second apps menu is where you can find those minutes, and as we talked about for chapter 4, a quiz, that alpha, the green button plus, is where we find those seconds. Just make sure you're in degree mode, okay? But coming back to your question on number 23, which should be right about here. We have a church with a steeple, which makes things just a little bit more complicated, because you can say to the top of the church building, but then there's also the top of the steeple. So if I were you, when you were drawing your picture, the base is easy because that's the ground. But from that point, that's somewhat away from your church, then you have the, well, I guess steeple wouldn't be across. There you go. Put the steeple. I know. Whatever, there's a steeple. And there's also the top of the building. Ta-da. So we have a point 50 feet. We have two different angles because one of them isn't going as high, isn't turning as much as the other one. So we have one that just says, I'm looking at the top of the building, and the next one says, I'm looking at the top of the steeple. It's like, okay, that's a little weird, but it says find the height of the steeple. This is very similar to that whole distance between the two towns thing that Nathan was working with me on Friday that maybe you guys were tracking with, or maybe you weren't. Because we can use opposite adjacent, that's a tangent, right? use tangent to find this guy's adjacent. We could call him like A1. We can also use the other guy to find the other adjacent. I can do adjacent over opposite. Oh, it goes the other way. Sorry, I guess it would be O for opposite, but then it looks like 0, so that's okay. Opposite over adjacent, and we could solve. And then we could do the other dude to be the other opposite over the adjacent and solve. And all we have to do to figure out how big the steeple is say take those two opposite sides and subtract them. Take those two opposite sides and subtract them. So it's as easy as multiplying over by 50. Make sure you're in degree mode. And then taking this guy. He's the shorter one, so subtracting him from that guy. Does that make sense okay? Kind of. So two different right triangles, two different tangents. Solve both of them for their adjacents and say, or sorry, their opposites. I keep on saying that. And then just say subtract them. One big old subtraction and you're done. But we also had number 29 that we had a question on. Let me get rid of the calculator. I don't think we need him anymore. And number 29 says angle of depression. So instead of being on the ground and counting up, oh, 29, wrong one. You guys okay? Go ahead and ask a question if you're stuck. What's going on?
Just explaining it.
Oh, okay, okay. On the last one or a different one?
The last one.
Do you need me to go any further? Or are you guys okay?
No, I think we're done.
Okay. I'm going to try to make these triangles a little bit more precise. This one's similar, to be honest. I think this one's harder. Because now all of a sudden you got like a mountain and a cell tower on top of a mountain. But if you think about it, isn't it super similar to the one we just had? You have one object and then you have something else on top of the other object. Cell phone tower, I don't honestly know what those look like. I probably should. But anyway, it's like the fake tree that we have. Don't we have one out here somewhere? We have one. Yeah. There's something fake and it's a cell tower. Anyway, we have a cell tower. We'll pretend it's a fake tree. That kind. It's 150 feet tall. Oh, they're giving me like the steeple size this time. They're giving me the cell tower height. And then they're saying, yeah, 1,200 feet above sea level. What is the angle of depression from the top of the tower to a cell phone user who is 5 miles away? So from the tower. Top of the tower. Sorry, I was trying to figure out what measure. Top of the tower to the cell user who is 5 miles away. But we don't know the theta. That's okay. What do we know? The 5 is how far away. But couldn't we also just make this 5? If 5 miles is how far away from the mountain. Now, okay, some of you are like, wait, where's the cell tower in the mountain? Okay, this is where it starts to get a little awkward as far as an ideal solution. So they're saying 5 horizontal miles away from the cell phone tower. So I know it's a little awkward because it's actually going into the mountain, but they're saying from wherever this is, its location, its GTS, go down, measure that way, it's 5 miles. So it is legal for me to measure that 5, or to label that distance 5. Now I have 150 feet. Uh-oh, this is miles. That's feet. That's one issue some of you might not have resolved. I have to get them all in the same units or else I'm in trouble. But then also, how do I know how tall? What's the one clue we haven't used? Why is it not 1,200 plus 150? Why is it only 800 plus 150? Yeah, you have to put it all together. So this person is 400 feet. They're not at the sea. They're not at sea level. They're a little bit above sea level, but not near as much. So you have to use those two clues to say, well, how tall is the mountain? Well, it's 800 above the person. So I have that 800, that's the mountain, and then I have the 150 at the cell phone tower. And remember, all of that is just feet. So what did you guys do? Did you go to feet or did you go to miles? You have to do some sort of conversion. Feet? Okay. So then, how many feet are in a mile? 280. Now I have feet. Whew! Which trig uses opposite and adjacent? Toa. Yeah, if you're not, like, if your brain doesn't jump there, just think so, opposite over hypotenuse. No. Ka, adjacent over hypotenuse. No, I need opposite over, Toa, tangent. So tangent of theta is equal to, who's over there? Who's over here? And now they're both feet, which is perfect, because I need, anyway, trig's always dimensionless. Maybe you don't really care, but that gives me a fraction. That's not my answer. How do I get to theta? Oh, divide by tan. That's a thing. Vehement, no. How do I undo tangent to get to theta? Arctan or tan inverse. You guys like arctan better. You use it a lot. Huh. Okay. Arctan both sides. I would say make sure you're in degree mode. That's just the one that makes the most sense to me. But you could have been in radians, I suppose. Tomorrow's quest, I'll probably say beforehand, change to degrees just to be safe. But if you want to go to radians at any point, you can. And all you have to do is just plug in tangent inverse of 950 over 5. Great questions on homework, and they were both really similar. It gets weird when you have something on top of something else and one reference point. 2 different triangles, usually subtraction with your Sofitel. Any other things from homework that you guys want me to talk about, clarify, explain?
I'm just curious, how do you plug in tan inverse in your calculator?
Oh, second tan.
Okay.
Yeah, second tan. You look above that tan, there's that little tan -1. And then 8, and I think you already checked degree mode. That would be a good one to stay. Yeah. Anything else? Oh, the cell tower? No, the mountain. The mountain is 1,200 feet above sea level, and the person is 400 feet above sea level. So I took that 1,200, and I was like, well, the person's not at the sea. He's 400 up. So do a little 1,200 minus 400 to be 800. Does that kind of make sense? So I didn't draw the sea, but the sea would have been down somewhere. So this guy would have been 400, and then this guy was 1,200. So that was a little bit finding the distance between. Yeah, that was weird, Griffin. Sorry. Thank you.
How many questions are going to be on the
Oh, well, that's more of a, let's talk about the quest tomorrow. So let's go ahead and get out of section 4.8. Let's get out of that. I'm going to leave this open just in case you guys want to ask me any questions on the review. Let me get out of that too. All right, as you guys are looking at the review problems, let's talk about that quest. First of all, you guys have already heard me say that a calculator will probably be a smart idea, right? Oh, sorry. Number 39 is black, and number 40 is green. And just leave that bottom set for me. Thanks. All right, kiddos. Section 4.5. Tomorrow's quest is going to be, what is it? 1, 2? I think a page and a half. I think it's going to be a page and a half. You are allowed to use your calculator on any section 4.8 word problems. However, section 4.8 word problems was not where this chapter or this part of the chapter began. What are you guys seeing who are reviewing right now? I see you, and you're not doing right triangles. What are you doing? Graphs of, waves, right? Sines and cosines and tangents and cotangents and cosecants and secants. you a multiple choice question on something to do with a wave and a wave graph. Maybe. I could do lots of graphs and say choose one, but do you think that will take up a lot of paper and a lot of space?
Show us one graph, tell us.
Okay, in homework, I did have ones where I gave you graphs or problems with graphs, and you had to find the equation. But think about like cutting it down. Don't multiple choice questions usually just ask you about like one aspect here or there? How can I do that with a wave? Period. Yeah. What's the period for this equation? What's the amplitude of that equation? How is this one shifted? In multiple choice, I'd just be asking you like one little detail, so you need to know all the different pieces. In a long answer, which there is one of them, I will give you an equation, and I will give you sinusoidal axis, what is it? Amplitude, what is it? Period, what is it? Initial point, what is it? Quarter cycle, what is it? And then I'll have a nice little graph and say, go. That would be a long answer, where I give you an equation, and I say, give me all the details. But multiple choice, I might just be asking you for like a little piece here, or a little piece there. And maybe one of them is just like transformations, like reflections. So, what do we got? We got one page, front and back. Oh. 4 multiple choice and 2 long answer. 3 long answer. 4 multiple choice and 3 long answer.
That's the question.
And because of what I've given you, it's actually non-calculator. What? Pause. When did you need the calculator? Degrees, minutes, seconds. That was chapter 4. Inverse trig that gets weird. Okay, yeah. Maybe that wasn't exactly the main point. Word problems, but pause. Couldn't I ask you to give me, like, set up an equation for the word problem, and that way you don't actually have to use your calculator to finish it? I know. The problem is, what I'm asking you as far as graphs and whatnot, I can't let you have your calculator. But the nice thing is, it's supposed to be a pretty short quiz, true? But wait a minute, like, at the end of the semester, you heard, what, like 3 different people today up in the front of chapel alone talk about how stressed everyone is, or at least assuming that you guys are. Why are they doing that? Why are they saying that? Because there's a lot going on. So, this quest tomorrow, could it be super overwhelming and crazy and ridiculous? Yes. Or it could be maybe a shorter, sweeter version. 1 page, front and back, 4 multiple choice, 3 long answer. I'm going to be very precise as to what types of problems are. Maybe it's not that I'm trying to trick you. Maybe I'm just trying to give you a shorter and sweeter version that if you have the main ideas, you should be okay on. Does that make sense? So don't think I'm trying to trick you. Just think I'm trying to give you a more condensed, concise, simpler version of maybe what would be a longer one if this was like in the middle of the semester at some point. You guys ready on the multiple choice hints? One of them is just taking a normal trig with a transformed trig equation and saying what changed. You've seen that in pretty much every chapter we've taken. What was the transformation? Was it a shift? Was it a reflection? Just a good old-fashioned, is it on the inside or on the outside? Is it time? Is it negative? A good old-fashioned transformation, but with a trig. Another one is going to be a unit circle question. Well, but that was the beginning of chapter 4. An inverse trig unit circle question. Remember how you guys gave me unit circle quizzes last week? Let me give you one sample inverse trig unit circle going backwards question that you can use to study. What if I was to ask you for arc tangent of negative root 3 over 3? It's just a sample problem. It's not the test problem. But what if I was to ask you for arc tangent or tangent inverse of negative root 3 over 3? It's unit circle. Could you get that? P.S. Do you want the answer just so that you can make sure you have it right?
Nope.
Square root of 3 over 3, 1 square root of 3. It's a pi over 6, but it's a negative pi over 6. Unit circle backwards question. You're going to have a trig of an arc trig. Oh, you guys asked me great questions on that on, Emma, was that Friday? Yeah. Trig of arc trig, and I did some great examples. Check out the video. Trig of arc trig. Maybe with just numbers, or maybe with an X in it. And then a word problem that you don't have to solve, you just have to set up an equation to use. And then the long answers are all the graphs. All the graphs, okay. One wave, which means it could be a sine or cosine, where I give you blanks for sinusoidal axis, fill in, amplitude, fill in, initial point, fill in, period, fill in, quarter cycle, fill in. Why? So you can get all this partial credit before you ever get to the graph. And then the only other long answers are maybe bouncing off and then finding vertical asymptotes. Remember with tangent and cotangent, I said finding vertical asymptotes? Hey, every year people ignore me when I say that. Finding vertical asymptotes, that's something to memorize. Vertical asymptotes, that's something to memorize. Review is due tomorrow. If you have questions, ask me on your way out the door. Don't stress, it's very concise, very open. Vertical asymptotes, please memorize.
Who's ready for walk? Me.
That's me. Oh my God. I almost tripped.
I was broke my leg just now.
Thank you.
Thievery.
I remembered.